Hi, everybody. Tommy Clayton here, middle school science teacher and OpenSciEd writer. Excited to dig into forces at a distance. This is lesson 11. And so we're coming off of lesson 10. And so we figured out some cool stuff about our ways to investigate. And so this lesson is really cool because we get to really plan our own investigation and try a lot of different things. There's a little bit to manage here with some materials because you have a lot of different experiments going on, but super cool lesson. Really exciting for kids to plan their own investigations. So let's dig in and give you a little bit of tips and tricks on how you can manage some of those materials while they're going on. So we're going to look at how we got here. We are going to take a look at this lesson at a glance. We'll look at a few key moments, and then we'll dig into some tips and tricks and some of the material management. All right, so let's remind ourselves how we got here. In the last lesson, we were curious about how the force really varied between magnets when they were closer together. And so we did some testing, we collected some data, and we realized that there was this relationship between distance and force. And so in this lesson, we're wondering more about what else determines the strength of those force pairs between two magnets, right? So what else can we mess with to see if that will affect that strength? So let's take a look at this lesson at a glance. This lesson is a 3-day lesson. It's an investigation lesson. It's going to take you about 30 minutes to get set up for the materials. There is going to be a hands-on investigation, a lot of them, and this is going to require some devices. We're going to be back to the simulation, but a new one this time. So on the first day, we have this chunk that happens, and this is really all about us figuring out what we were going to test. So figuring out the variables that we're going to test and coming up with a plan for that investigation. Then on the second day, we're actually going to carry out that investigation. It's going to take us some time to collect that data. And then we're going to make sense of that data and get a chance to do some walking around and seeing what other students collected as they tried a different variable. So we're going to see a lot of the patterns in our data. And then on that third day, we're really going to put it all together and we get to share all of our findings in a scientist circle. And then we get to find out a little bit more about how these things relate to the magnetic field. So we're going to see how the entire field gets stronger or bigger depending on the variables. And then we're going to figure out ultimately how we can apply this back to the speaker that we started with when we wrap up everything in the next lesson. So essentially on the first day, we figure out our plan. On the second day, we carry out that plan and collect the data. And then on the third day, we kind of put it all together to figure out that a lot of different variables can affect the strength of the magnetic field, and those variables cause the magnetic field to get stronger and bigger. So you can do things like increase the number of magnets, the size of the magnets. You can increase the number of coils. You can make the coils smaller. You can increase the batteries or the voltage. All of that will make the magnetic field bigger and stronger. So let's take a look at some key moments. There's a lot going on in this lesson. In part 2, so we kind of navigate in and take a look back to see what other variables we were curious about. So that leads us to part 2, where we plan our investigation. So we work in groups and we look at the tools that we have available again. So we're going to use the same setup to measure force, the scale with the magnet taped with the ruler. Except this time we have access to a lot of other things. So we have access to different size magnets. We can get multiple magnets. We are now able to access the electromagnets, so the setup of the coils. So we can mess with the number of coils, the size of the coil. We have access to more batteries, so we can mess with the voltage. But we are going to still measure force, that weight in ounces, and we're going to use the same scale. And this time we're going to control the distance. We're going to make sure that we want to keep that the same for all of our trials. So we come up with a plan, and then we get some feedback. We get to meet with another group, and we use a rubric to give each other feedback on our plan and then make some adjustments based on that feedback. So then in part 5, after we've kind of revised our plan, we're actually going to carry out that investigation. So just like we did in the previous lesson, we're going to tape a magnet to the scale. We'll zero it out. And then we're going to test our variable. Each group's going to be doing a different variable. So some are going to try different diameter magnets, or using a lot of magnets to change the thickness of the magnet. Some are going to try adding more coils, or messing with the diameter of the coil, but the same number of coils. And then some get to mess around with the amount of current, right? And then we're going to flip the orientation and repeat that, right? So we really get those pushes and those pulls. And so in part 6, we're going to take all that data, we're going to put it together and develop a poster to share with our peers. And then in part 7, that's when we're going to actually do that gallery tour. And so this is where you'll get to, students will get to see what other groups did, to find out more about their relationship. And then they're going to leave some feedback on the way that students represented their data, shared some claims, and came up with a visual representation of the relationship that they discovered. So in part 10, then after we've kind of thought about this data, we have some wonderings about the magnetic field, because we can't see it, right? So we're like, cool, let's go back to our interactive, and we get a new version of the interactive. And this one is packed with the ability to mess with lots of different variables. So all the different variables that we tried in our classroom are now available in this simulation. So we get to try those and see how it affects the magnetic field as a whole. So this is going to lead us to our last lesson. So after this lesson, we take stock of everything that we figured out. We explain our original phenomena, and then we apply our thinking to a new scenario. So we take a transfer task. Okay, let's talk a little bit about tips and tricks. There is a lot happening here. In the part where they're conducting the investigation, we want to remind ourselves of what we figured out in lesson 10, that the numbers can bounce around a little bit, right? So we want to try to be as still as we can. And we want to make sure that we're zeroing that scale out at the beginning. We're going to measure everything from eye level. This time we are controlling the distance. So we really want to be as specific as we can about the distance we are holding our magnets or our coil away from the other magnet taped to the scale. Just like last time, we're going to set the scale to ounces. If we are using the coils, we want to do quick tests. Remember, they get hot and they drain the battery pretty quick. So if you're doing this multiple classes, you really want to pay attention to that battery usage. If possible, if you have access to rechargeable batteries, that's great. And I would say really try to minimize the number of groups that are testing with the coils and the batteries. So if you have, larger classes where you need to double up some variables, double up the ones where students are using multiple magnets or messing with the diameter of the magnets, and really just have one group do something with, the number of coils, and a separate group do something with, the diameter of the coils or the batteries, whatever the case may be. Just keep an eye on the battery usage, because that can lead students to get some inaccurate data if the batteries themselves are in fact weak or drained. Okay, so when the students are analyzing the data, this is just a reminder from the other previous lesson. We want to make sure that they are multiplying their measurements by 100. It's going to make it a lot easier for them to graph, and remind them that the negative numbers don't necessarily mean that the relationship is different. Again, they can take their graph paper and fold it on one another, and they'll see those lines really line up to see that the relationship is the same, whether it's attractive or repulsive. Okay, no new words to add to our word wall. And the only poster that we are working with is that cause and effect tractor. So we're going to add some new stuff, quite a bit of new stuff related to all the different variables that we tested. Okay, so that's going to do it for lesson 11. Hopefully you found some great tricks in here to manage all the different investigations that are happening. I think students are really going to enjoy taking ownership over planning the investigation and trying something different than the rest of their classmates. Come back and join us for lesson 12. It's the last lesson of the unit, so we'll see how we put all of this together. Thanks for watching, and come back and see us again real soon.